Hi guys, good day. A lot of you guys could not have made it to our online class because of connection problems. And I didn't want to leave you hanging in terms of the homework, so I just did this little video to correct the homework because um, I think that simultaneous equations and the method of substitution is particularly important. Now, at the end of the day, the method of substitution, which is what we are practicing here, is the most difficult method in terms of simultaneous equations, in solving simultaneous equations. Um, is the most difficult method, but it's my personal favorite method, simply because you will always get a sure answer once your algebra is strong. So I like to focus on this method simply because in order for you to be good at this method, your algebra needs to be strong. And if your algebra is not strong, then practicing this method is a good way to make your algebra strong, right? So let's just get started with this. So the first equation that I have here that you all had for homework was 5x, and let me just make this a little smaller there, right? So the first equation that you guys had was number 1, 5x plus 2y equals 16, and negative 3x plus 4y equals negative 7. We'll call this equation 1, and we'll call this equation 2. Now we know from our process in terms of what we did with substitution, we don't have any easy options here because we don't have a x by itself, we don't have a y by itself. So really and truly, we could choose any equation. We could literally choose anything to make the subject to the formula. I'm going to choose equation 1 simply because I'm seeing here that equation 2 has all of these negative signs in it, and I don't want to deal with all of that negativity right now, yo. So let's go with equation 1. So what I'll say is that from equation 1, 5x plus 2y is equal to 16. Now, with this, I could make either x or y the subject to the formula. So let's go with y. So let's go with y. So therefore, 2y is equal to 16. And I just basically took the 5x and I threw it over. So it would be minus 5x. And then y is equal to 16 minus 5x, all divided by 2. So now I have y as the subject to the formula. I have an expression that represents y. So I am going to sub y in equation 2, right? Because I used equation 1 to get this in the first place. So I'm going to take this and sub it in equation 2. So what is equation 2? Negative 3x plus 4y is equal to negative 7. So wherever I see y, I am going to put this expression here, 16 minus 5x, right? So what I'm going to have is negative 3x plus 4y, and y is 16 minus 5x, all divided by 2, right? And that is equal to negative 7. And thankfully, I don't really have to deal with this fraction because this 2 will cancel with this 4 to give me 2. So now I have negative 3x plus 2 into 16 minus 5x is equal to negative 7. The 2 is going to be multiplied by the distributive law, so I have negative 3x plus 2 times 16 gives me 32, and then 2 times negative 5x gives me negative 10x is equal to minus 7. So because we have minus 7 there, let's take this 32 and throw it across there. So now we have negative 3x minus 10x is equal to minus 7 minus 32. So on this side, minus 3 minus 10 gives us negative 13x, and that is equal to 32. Negative 7 minus 32 gives us negative 39. So therefore x is equal to negative 39 divided by negative 13. The negatives will cancel and I will get x to be 3. Right? So now that we have x is 3, we sub x equals 3 in any of the equations, really, it'll work. And since we used equation 2 to get this x is equal to 3, let's sub it in equation 1 just to be sure. All right? So minus 3 and x is 3 plus 4y is equal to minus 7. So that means negative 9 plus 4y is equal to minus 7. 4y is equal to minus 7 plus 9. Right, so then 4y is equal to positive 2. Y is equal to positive 2 divided by 4, which is a half. Therefore, x is equal to 3 when y is equal to a half. Now, what are we actually doing when we are solving simultaneous equations? Remember, each equation represents a line. So if we look at our GeoGebra calculator here, we could see, and I have the two equations here. So we have the first equation, 5x plus 2y is equal to 16, and that forms that line. And then this next equation, negative 3x plus 4y equals negative 7. And we could see that where they intersect, the point of intersection there, x is 3 and y is a half. So when we solve simultaneous equations, what you're actually doing is you're actually finding that point where both of the lines are intersecting each other, right? So let's try to tackle some of the other questions now. Right, so we have question 2 here. And question 2, we have 3x plus 2y is equal to 19. Let's call that equation 1. And then we have 5x minus 2y is equal to 5. Let's call that equation 2. Now, as I said before, these equations, they don't really have any easy way out in terms of making, x or y the subject to the formula. So laziness is not an option here. So we could literally choose any x or any y to start this off with. So how about let's choose equation 2 this time. So from equation 2, 5x minus 2y is equal to 5. So let's make x the subject to the formula. So I'll take this negative 2y and I'll throw it across. Therefore, 5 is equal, so 5x, is equal to 5 plus 2y, right? The negative 2y became plus 2y when I throw it across. Therefore, x is equal to 5 plus 2y divided by 5. And I'll just leave it like this for now. Yes, it can be simplified, but I'll leave it like this for now. Hopefully it works out, right? So we got this from equation 2. So let's sub x in equation 1. So equation 1 is what? 3x plus 2y is equal to 19. So what I'm going to do is I'm going to take this expression and I'm going to put it wherever I have x, right? So that means that I have 3x, which is 5 plus 2y divided by 5, and that is plus 2y gives us 19. Now I can't cancel anything off here. The 3 cannot cancel the 5. Nothing could cancel off really. So I could have two options. If I want, I could multiply 3 by the numerator. Why can I multiply 3 by the numerator? Because remember, 3 is a fraction, 3 over 1. So I have two fractions, 3 over 1 multiplied by 2y over 5. And what do we do when we multiply in fractions is we multiply the numerators, and the denominators, right? So that is one option. The other option is that I could actually simplify what is inside of these brackets first and then multiply by 3 after. Now, any one you choose will work out the same answer, right? So let's just multiply by the 3 one time. So now I'll have 3 multiplied by this numerator here gives me 3 into 5 plus 2y. All of that is being divided by 5 plus 2y is equal to 19. 5 3s are 15 plus 3 times 2 is 6y. All divided by 5 is equal to 2y. No, sorry, plus 2y, all right, is equal to 19. All right. Now, look at this. I have 15 plus 6y all over 5. What this means is that the 15 is being divided by the 5, as well as the 6y is also being divided by the 5. So what I could do is I could actually split this up. I could actually say that, all right, 15 is being divided by the 5 plus the 6y is being divided by the 5. Yeah? So now I'll have 15 divided by 5 plus 6y divided by 5 plus 2y gives us 19. Right? So you see how this substitution thing really helps us to practice a lot of cool stuff, like say splitting up this fraction into 2 different fractions. So we really get to practice a lot of algebra in this substitution method, right? So how about this 6y over 5? 6y over 5. We see that this 6 is being multiplied by the y. So isn't this the same as if I had a 6 over 5 multiplied by y over 1, right? So where the 5 is being multiplied by the 1 and the 6 is being multiplied by the y. So that means that I could pull the y outside and I could have 6 over 5 y. Yeah? So I could even simplify this further to say, well, 5 into 15 is 3. So that's 3 plus 6 over 5y plus 2y is equal to 19. How about I take this 3 and I throw it across? So I now have 6 over 5y plus 2y is equal to 19 minus 3. Right? Now what is 6 over 5? That is 1 and 1/5 y plus 2y is equal to 19 minus 3 is 16. Now, what I could do here is I could actually add these. 1 and 1/5 plus 2 gives me 3 and 1/5 y. Right? I just add the whole numbers, 1 plus 2. Right? So that's 3 and 1/5 y is equal to 16. So therefore, let's make this into an improper fraction. 5 3s are 15 and 1 is 16 over 5. Y is equal to 16. Therefore, y is equal to 16 divided by 16 over 5. And of course, what do I do when I divide by a fraction? Is I invert and multiply. So therefore, y is equal to 16 multiplied by 5 over 16. And well, look at that. these 16s cancel quite nicely. Therefore, y is equal to 5. Right? And now that we have a value for 5, let's sub y is equal to 5 in any one of the equations. It really doesn't matter. But since we used equation 1 to come up with the value for y, let's sub it in equation 2. So what is equation 2? 5x minus 2y equals 5. 5x minus 2y equals 5. Let me make sure I got that right. Yep. And we just sub in y is equal to 5. So therefore 5x minus 2 into 5 is equal to 5. 5x minus 5 2s are 10 is equal to 5. 5x is equal to, let's just take this 10 and throw it across one time. 5 plus 10. 5x is equal to 15. Therefore, x is equal to 15 divided by 5. X is equal to 3. And so we have the solution being when x is 3, y is 5. And let's just check that and see. Now, before we check it, we saw that the substitution method is a little bit lengthy. It really helps to work out your algebra. But I would like you to not be afraid of the substitution method because it really is super important for you to be good at algebra. If you are good at algebra, then nothing in math will ever bother you, because math up to add math, CSEC, add math, A-level math, university math, it's all about algebra. So if you are strong in algebra, you will not only conquer math, but you could conquer physics, chemistry, biology. Algebra plays a role in everything. Accounting, business management, statistics, anything you could dream of, managing a business, entrepreneurship, algebra plays a role. So being strong in algebra is super important for the future, right? Now let's just check and see if we got our answers correct, right? So x is 3, y is 5. This seems like pretty okay answers, right? So let's check our graphic calculator and see this equation here being the equation for 3x plus 2y is equal to 19. And then I have the equation for 5x minus 2y is equal to 5. And let's see where it intersects. And we can see the point of intersection here is indeed x is 3 and y is 5. So remember, simultaneous equations is all about finding that point where these two graphs intersect. Yeah. So let's just check this one here. And I could see that there is no easy way out for number 3. So I could make anything the subject of the formula. So let's go with, from equation 1, 3x minus 2y is equal to negative 1. So 3x is equal to negative 1 plus 2y. Right? I could actually flip this. 3x is equal to 2y minus 1. Right? I just put the positive in front. X is equal to 2y minus 1, all divided by 3. Now let's sub this in equation 2. So what do I have for equation 2? Equation 2 is 4x plus 7y is equal to 18. Now I'll just take this x and I'll put it wherever I see x in equation 2. So that's 4 into 2y minus 1 divided by 3 plus 7y is equal to 18. Now, I can't cancel the 3 and the 4, so I'll just multiply the 4 throughout the numerator. So I'll have 4 2s are 8y minus 4, and that's all being divided by 3, plus 7y is equal to 18. Now let's split up this fraction here. 8 over 3y minus 4 over 3, because the 8y and the 4 are both being divided by 3. So I could split up the fraction like that. Plus 7y is equal to 18. Let's take this 4 over 3 and throw it across. The negative 4 over 3. So I'll now have 8 over 3y plus 7y. And that is equal to 18 plus 4 over 3. Now, if I was to change these things to, let's try changing these things to mixed numbers. So 3 2s are 6, 7, 8. So that's 2 and 2 over 3y plus 7y is equal to 18 plus 1 and a third. Right? Now, 7 plus 2 is 9. So this is 9 and 2 over 3. Y is equal to 18 and 1 is 19 and a third. Right? So now let's try to flip these things back to improper fractions. And if we flip these things back to improper fractions, we'll see that 9 3s are 27, 28, 29. So that's 29 over 3y is equal to 19 by 3 is 57, and 1 is 58 all over 3. Now we'll take the 29 over 3 and we'll throw it across. So I have y is equal to 58 over 3 divided by 29 over 3. And what's going to happen here is whenever you're dividing by a fraction, you invert and multiply. So y is now equal to 58 over 3 multiply by 3 over 29. So thankfully these things cancel, and what is 58 divided by 29? And that works out to be 2. Well, nice. So we get a nice round easy answer here. So now we're gonna sub y is equal to 2 in equation which one? Well, we used equation 2 to get the y value. So let's sub it in equation 1, right? So we'll sub it in 3x minus 2y is equal to negative 1. So we put in y is equal to 2. 3x minus 2y, which is 2, is equal to negative 1. 3x minus 4 is equal to negative 1. 3x is equal to negative 1 plus 4. 3x is equal to 3. Therefore, x is equal to 1. So we saw here that the answer here gives us, no, when y is equal to 2, x is equal to 1. And let's just check and see if that's right. Essentially, we have our two equations here, and we see the intersect point of the two lines. When y is equal to 2, x is definitely equal to 1. Right? So just a reminder that when we solve in simultaneous equations, we are actually finding that point where both of these equations intersect. Alright, so let's tackle number 4. We see here that 2x plus 3y is equal to negative 8, and we'll call that equation 1. And 5x minus 2y is equal to 18. We'll call that equation 2. Now let's try from equation 2 5x minus 2y is equal to 18. And I'm going to throw the 2y across so everything will be nice and positive. So therefore 5x is equal to 18 plus 2y, and x is equal to 18 plus 2y, all divided by 5. Now sadly the 5 cannot go into the 18, the 5 cannot go into the 2, so I have to leave it like this. It's not very pretty, but we're going to sub this in equation 1. Alright, we got this from equation 2. Alright, so we're going to sub this in equation 1. What is equation 1? Well, equation 1 is 2x plus 3y is equal to negative 8. And wherever I see x, I'm going to put this value. So therefore 2x, which is 18 plus 2y, all divided by 5, plus 3y is equal to negative 8. So what we'll do now is we'll recognize that this 2 cannot go into this 5 in any way, which is sad for us. It would have made our life easier. So we'll have to multiply. The 2 by the numerator. So 18 times 2 gives us 36. Plus 2 times 2 gives us 4y, all divided by 5, plus 3y is equal to negative 8. So because 5 cannot go into 36 or 4, means that I can't just cancel anything. I'll have to split the fractions. So thankfully, because of the choice that we made to use equation 2, we don't have any negatives to deal with. So I now have 36 over 5 plus 4 over 5y plus 3y is equal to negative 8. Let's just take this 36 and throw it across. So I now have 4 over 5y plus 3y is equal to negative 8 minus 36 over 5. Now, what is 4 over 5 plus 3? That is 3 and 4/5. Y is going to be equal to negative 8 minus, and let's just change this 36 over 5 into a mixed number so it'll be easier to deal with. So 7 5s are 35 and 1 is 36 over 5. So I now have minus 8 minus 7, and that gives us 3 4 over 5y is equal to negative 15 and 1 over 5. Now let's switch back everything now to improper fractions. So 5 3s are 15, 16, 17, 18, 19. So this is 19 over 5y, and that's equal to, now what is 15 times 5? That is 75 and 1. So that's, 15 times 5 is 75 and 1 is 76. So that's negative 76 all over 5. So now y is going to be equal to negative 76 over 5 divided by 19 over 5. And so we just invert and multiply. So y is going to be equal to negative 76 over 5 multiply by 5 over 19. So thankfully the 5's cancel there. And let's see what is negative 76 divided by 19, and that gives us a nice value of negative 4. So y is equal to negative 4. So at least we're getting some nice clean answers for these questions here, right? And since y is equal to negative 4, we got that from equation 1. So let's sub it in equation 2. So sub y is equal to negative 4 in equation 2, which is 5x minus 2y is equal to 18. So 5x minus 2 into negative 4 is equal to 18. Now minus 2 times minus 4, 5x plus, a negative times a negative is a positive, 4 2s are 8, is equal to 18. I could kind of see what's going on here already, right? 5x is equal to 18 minus 8. 5x is equal to 10. Therefore, x is equal to 10 divided by 5. X is equal to 2. So we see in here that for this equation, when y is negative 4, x is equal to 2. And how about we just check and see if that is if that is true in our equations here. So we have the first equation, 2x minus 3y is equal to negative 8. We have the second equation, 5x minus 2y is equal to 18, and we can see there that the point of intersection is indeed x is 2, y is negative 4. So that is it for the simultaneous equations homework, the corrections. So I hope you guys got some good solutions. Remember, you were supposed to do these questions using the substitution method. Now, the substitution method is quite the most difficult method, but the great thing about knowing the substitution method is that it will work for every simultaneous equations you ever come across, no matter how hard it is. Because imagine you have a situation where you have the root of 2y plus pi x is equal to 1 and then the other equation is the root of 3y plus the root of 5x is equal to pi, right? Let's just say you have a situation like this, then you cannot use the other methods. The other methods might not help you out that well. The so-called quote-unquote easier methods will not work. For something like this, you would have to use your substitution method. So the substitution method is super important. So for the next class, if you check the classroom page, you will see that there is an assignment that is due for the next class, and that assignment is on simultaneous equations. Please, you must use the substitution method, right? So that was it. I'll see you guys next class.